Hello. Okay, I'm sorry for the delay, but we are ready to start now. We had some minor technical issues, but we're all set, so I hope everybody can hear me. Please, I see some people joined our online study session. Raise your hand if you can hear me, and we can start with our third study session. All right, I see somebody raise their hand. Let's wait a couple of more. Yay, okay, everybody is raising their hand. We can start. And I'm going to go to my first slide, which means my first question for this online study session. And thank you so much for joining us today. This is the first question. I hope you guys printed out your guide and had a chance to start doing the problems yourself. But this question says, for what values of the unknown variable is the rational expression undefined? So that means when we're having a rational expression, the only time this problem is undefined is the denominator is 0. So the way that we can find out when the denominator is 0 is if we are taking, sorry, let me go back and change to my pen real quick. Right there. Oh no, not red. How about dark blue? Very good. Okay, so we're taking our denominator and setting that equal to 0 to find that value when the denominator is undefined. So let me write it over here. Y squared minus 49 is equal to 0. So looking at this, this reminds me of the section when we were dealing with factoring. So I have two terms and a negative sign, and both of these terms look like perfect squares, so I'm going to use factoring the difference of two squares. So I can write my empty sets of parentheses. All that is equal to 0. Now the square root of y squared is just y, and I have that twice. And the square root of 49 is 7. I also have that twice. And then I know that my signs need to be opposites, and it doesn't matter where I put my negative sign and where my positive sign, because both of these are multiplied and multiplication is commutative. Okay, I'm not done here. So I'm taking each part and I set it equal to 0. So y minus 7 is equal to 0. And then also y plus 7 is equal to 0. And I'm going to solve for y by adding on this side 7 to both sides, which leaves me with, sorry for that, y equals to 0 plus 7 is 7. And on the other side, I have to subtract 7 from both sides. So here, I should have y is equal to negative 7. And if you look at your study packet, that should be answer choice B. So referring to this kind of statement, that means whenever y is 7 or negative 7, that would make this rational expression undefined. And we can try this out by plugging 7 into y right here. So 7 raised to the second power, so 7 times 7 is 49, and 49 minus 49 would equal 0. So that is the value that makes the rational expression undefined. And the same happens if you plug in negative 7. Let me know if you guys have any questions. I have Johnny working with you guys and seeing if you guys have questions, answering you by texting, and if it's a question that concerns everybody, she will let me know and then we work it out. Hi guys. So I think no questions. We can move on to number 2. So this one says reduce to lowest terms. This is also a rational expression, so I'm going to use my factoring methods to help me reduce this rational expression. If I look at the numerator, I have 5x minus 10, and I'm choosing to pull out the GCF. I notice that both of these terms, 5 and 10, share a greatest common factor of 5. So I'm pulling out the 5, and I am left with x minus 2. If I look at the denominator, again, I have two terms, a minus sign, and both of these are perfect squares. I can choose factoring the difference of two squares, as I did in the previous problem. So I have my two binomials. I square root the first term, so I get an x and an x. I square root the 4, so I get 2 and 2. And again, I have opposite signs, so I need a minus and a plus, or plus and minus. It's your choice. Now, when I have rational expressions, I can cancel out what's exactly the same from the numerator and denominator. It's like similar to reducing fractions. So this one is exactly the same. I can cancel out, and I am left with 5 in the numerator and x plus 2 in the denominator. I can check if there's anything else I can reduce, but I don't see that they have anything else in common, so this should be my final answer. In your packet, that is answer choice D. Okay, you guys doing great. No questions so far, but let's go to question number 3. This one says multiply and simplify. Okay, so there's a lot of stuff going on. We have basically two rational expressions that are multiplied together. So a lot of factoring, basically 4 times factoring. So I'm going to start right here with this, and I'm going to factor, and this is just the normal way of factoring a trinomial. So because I have a coefficient of 1, I can write my empty sets of parentheses. Then I square root my first term, which is an x and an x. I bring down the first sign, so that's a plus, and then I multiply the two signs together to give me the second sign. A positive times a positive is also a positive. And now I have to look for the factors of 18. When you have the same signs in here, I need to add to give me the middle number, which is 9. So which factors of 18 add to give me 9? I'm going to let you guys answer it, so I don't do all the work here. Please come up with 2 factors and type them into the chat box to help us out with the first factoring problem. I need 2 factors of 18 that will add to give me 9. Do we have some responses? Okay, I see some factors. It's 6 and 3. Very good. And because both of the signs are the same, it doesn't matter in which order you have to put them. So give me just a quick second here to help my coworker out. So let's move on. That is correct. So let's go to the next problem. I'm going to do the denominator now from this problem, which is also factoring. In this case, I noticed that this is possibly a perfect square trinomial because the 36 is a square root. The first term is a square root, and the 12, I get that by multiplying the first and the square root of 36 together, and that 2 times, that will give me 12. So I can use this method to factor this problem, which means I have an x and an x, the square root of 36, which is 6 and 6, and this sign in front of the middle term would determine the sign of my parentheses, which would mean both of them are positives. Okay, so this is multiplication, and now moving on to the second part, the factoring the numerator. And this looks like there's nothing particular going on other than that they have a greatest common factor of x. So I'm going to pull out an x from this numerator. When I take out the x, I'm left with one x inside and then just a 6. So one more trinomial left to factor. And this again is a regular trinomial with a coefficient of 1. So I can just write my empty sets of parentheses, square root the first term, which is an x and an x, bring down my first sign, multiply the two signs together to give me the second set, which is a positive times a positive. So I got a positive. And again, this is for you guys. Find the factors of 15, the same signs, that will add to give you the middle number, which is 8. Right here, I forgot to put this in right there. So I'm going to give you a few seconds, find the factors of 15 that will add to give you 8. Johnny, do we have?
Yes, we got 1.
Okay, so what is the correct answer?
5 and 3.
5 and 3, very good. And again, because the signs are the same, it doesn't matter where I put my 5 or my 3. Right there. So I'm done factoring everything. And because this is multiplication, I can basically just connect this fraction bar, and now I can cancel out everything that is on top with the exact same thing that's in the bottom. So let's start over here. I got an x plus 6, x plus 6. I got an x plus 3, and right down here, x plus 3. Then again, I got another x plus 6 and x plus 6. And let me see, anything else? Nope, nothing else cancels. So on top, all I have left is an x, and in the bottom, all I have left is x plus 5. So this is my final answer for question number 3, and this is question number 3. This is C. All right, thanks for helping on this one. If there are no questions, let's move on to number 4. So we did multiplication, now we're going to start doing division of rational expressions. So if you're dividing rational expressions, the only extra step is that you're converting this division sign to a multiplication sign. And as you may have learned by dividing fractions, the rule of keeping the first one, changing the sign to multiplication, and flipping the second fraction. We're going to use the very same rule. So we're keeping the first fraction, we are changing this division sign to multiplication, and we just taking the reciprocal or flipping that second fraction. So now the 30y cubed is in the numerator and the x cubed is in the denominator. Again, because this is multiplication and I have anything I can factor, or this is not really a factoring problem because all this is basically multiplying together. So I can cancel anything on top with anything in the bottom. And I am going to cancel, and I hope this is not confusing for you guys. You basically can also multiply the top together, multiply the bottom together, but I'm a little bit lazy. I don't have a lot of time, so I'm just going to start canceling out. For example, I have y4 in the bottom and y2 on top. So because this is division, the rules for variables with exponents is you subtracting. Or you can do your little side work of having 2 y's on top and 4 y's in the bottom, and then 2 of these would cancel out, so you're left with 2 in the bottom. But as bigger the exponents get, you should have a better rule than having to draw it out. So the rule is you subtracting them. So you have 2 on top, 4 on the bottom. You basically subtract 2 minus 4, which gives you a -2, and negative answers should go in the denominator. like right here you have the 2 y's in the denominator. So I'm going to cancel these out. This y is gone all the way, and here I'm left with 2 of them. So now I'm looking at, I got an x here, which has an exponent of 1, and x cubed in the bottom. Again, I subtract 1 minus 3, which is a negative 2, so negative answers should go on the bottom. So I'm left with 2 x's here, and this one is gone. Now I have y squared left here and y cubed here. I can do the same thing. I can subtract them because I can connect this. This is basically just the division. So 3 minus 2 gives me 1. So that's a positive answer, and it should be in the numerator. And this y, oops, is all the way gone. I can do the same thing with the numbers and check if there's anything I can take out. For example, I notice that the 5 goes into 30. So I can take out a 5 from 30. 5 goes into 5 one time, and 5 goes into 30 6 times. Okay, so there's nothing else I can cancel out. Now I just need to make sure that I put everything back together. So I got a 7 right here and a 6. This is all multiplication, so 7 times 6 is 42. Then right here I got a y to the 1 power, so basically that's just a y. And let's see what we got left in the denominator. The 5 is gone, the y is gone completely. Right here I got an x to the 2nd power left. Okay, and in your packet, this is question 4. This is answer choice B. I know this is a little bit confusing and everybody has to find their own style. So like I said in the beginning, you could have also first multiplied the numerator by multiplying the numbers. 7 times 30, which is 210. And then when multiplying the variables, you basically add the exponents. So you would have x, and this originally was a 3, so y squared, y3, that would have given you y fifth. And then in the denominator you had a 5 and y to the 4th, and then if nothing to multiply, so the x to the 3rd. And then you could have done the cancellation, so 210 divided by 5 is 42, and then here 1x, 3 in the bottom, so x squared, and wait, I'm missing a y. Oh, I had y4 right there. Okay, so 5 on top, 4 in the bottom, leaves me with 1 y on top. The same answer. So this one required me 2 steps, this one only 1. Whatever is easier for you, the main thing is you don't do any mistakes and get the correct answer. So if there are no questions, let's move on to number 5. This is another one, divide and simplify, but this is a little bit more complex. So again, we need to use factoring to help us out here. We need to factor everything we can, and again, because of the division sign, we have to rewrite our problem. So let's start with factoring this side, because we know that the first fraction stays the same. So this is a trinomial, coefficient of 1, and I see that 144 is a perfect square as well as the first term, so I can use my method of factoring perfect squared trinomials, which is writing my 2 binomials, square rooting the first term, which is an x and an x, square rooting the last term. The square root of 144 should be 12 and 12. And then the sign in front of the middle term determines both of the signs, so both of these should be negative. But if you cannot identify these as perfect square trinomials, then you could just do it the regular way, like we factored some of the other problems before, of finding your factors on the side. Okay, done with the numerator. Let's go to the denominator. And I would choose to factor by pulling out the GCF. I noticed that both of these terms have a common factor of 5, which is their greatest common factor. So 5x divided by 5 leaves me with an x, and then 60 divided by 5 leaves me with 12. Now, remember, change the sign to multiplication and flip. So changing the sign to multiplication and then flipping these. So 30 now is on top. And this, again, I can use greatest common factor to factor that one, because both of these have a factor of 6, and I'm left with x minus 12. Okay, so now I can cancel numerator and denominator. Right here, this is the same. Then here I got another one. That's the same. And I can either multiply these two together, or notice that the 30 will cancel out with both of these. So let me just rewrite it for you guys to see it more clearly. And 5 times 6 is also 30. And if I simplify that, what do I get? I'm going to let you guys answer this, because a lot of times students get confused with this. And I'm going to give you guys two choices. Is it 1 or is it 0? And I got the correct answer here. Yay! It's 1. So don't get confused. Does not cancel out completely. It's 1. Nice job. So if there are no other questions, I'm going to switch with Johnny now to get a little break. And she will be doing the next 5 questions.
Good morning. All right. Thank you, Deanna. And number 5 was letter D. Okay. So let's keep going. So number 6, subtract the rational expression, and we're going to simplify your answer in lowest terms. So you want to remember, to add and subtract a rational expression, you have to have common denominators. And so luckily, what we notice here, we do have common denominators. The denominator for both expressions is 4x. So we have common denominators, we just keep that denominator and combine the top. Now this is a subtraction, so be very careful, because you want to subtract this entire expression. So that means when we combine the top, we want to distribute this negative. So I can rewrite the first numerator, and then I'm going to distribute the negative, so that's minus x, and distribute the negative again will be minus 6. And so we have common denominators, so we're just going to keep that denominator all over 4x. And so now we're going to just combine like terms. So x minus x is no x, so the x's cancel. And then negative 6 minus 6 is negative 12 over 4x. And remember, we want to simplify to lowest terms. So negative 12 divided by 4 is going to be negative 3. And that x is going to be at the bottom. So our final answer is negative 3 over x. And that letter would be letter C. Letter C. Okay? All right. So here's another subtraction, subtracting the rational expression. And we almost have like same denominators, but we don't. So this one is x minus 6 over x minus 5. minus x plus 3 over x plus 5. So we need to get the least common denominator. We need to get common denominators. So basically, this denominator is x minus 5. This one is x plus 5. If our denominator was x minus 5 times x plus 5, then we can combine the top and use our new denominator. So this is our least common denominator. This first one needs the x plus 5. But if you multiply the bottom by x plus 5, you have to multiply the top by x plus 5. And the second denominator is x plus 5. It needs an x minus 5. So we're going to multiply it by, oh, okay. Sorry about that. So I need an x minus 5 for this denominator, but again, I can't multiply the bottom by this and not the top, so I need to keep it equivalent. Okay, so now let's work with the top now. I'm just going to write out what we have. So we have x plus 5 times x minus 6, I'm focusing on the numerator, minus, now notice I put this in parentheses because I want to distribute that negative eventually, x plus 3 times x minus 5. And remember, the whole point of this was to get a common denominator. So I'm going to put that all over our common denominator now. Okay, so now we're going to have to do a lot of multiplying, distributive property or FOIL, to eventually simplify and get our answer. So I'm going to first FOIL or distribute these two binomials, then I'm going to do these two binomials, and then I'm going to distribute the negative. That's the order that I'm going to use. So for the first binomial times binomial, it's going to be x squared first, outer, minus 6x inner, plus 5x, and last, minus, let's do the second pair of binomials, x squared minus 5x plus 3x minus 15. And all of that is over that same denominator. Whoa, okay. Over that same denominator. And you can do a lot of these steps at one time, but I'm just writing it all out so you guys can know what we're doing. All right, so now I'm going to combine like terms here. So that's x squared, let me run out of space, x squared minus x minus 30. And then I'm going to, up here, combine this, I don't have to write too much. Negative 5x plus 3x is negative 2x. So then when I distribute the negative, I'm going to have negative x squared. Negative times this negative will be positive 2x. And negative times this negative 15 is positive 15. X minus 5, x plus 5. I've got to get used to this pen. Okay, so now let's combine like terms. So x squared minus x squared is 0x squared. So that's gone. Negative x plus 2x is x. And negative 30 plus 15 is going to be negative 15. Okay? So now, bottom, we've got x minus 5, x plus 5, and then we want to see if we can cancel out anything, but I'm actually done because there's nothing else I can factor, and there are no common factors, the numerator and denominator, to cancel out. This is actually my final answer. And that letter would be letter B. All right. And any questions? There's a lot of different steps in that problem. And like I said, sometimes you can do more than one step at a time, but I just want to write it out very carefully so everyone can kind of see what we're doing. And if there's no questions, we'll move on to number 8. So find the LCD of the rational expressions. So it gives you 2 rational expressions, and all they want us to do is to determine what the LCD, or least common denominator, would be. So in order to find that out, we want to make sure we know the denominator's factored form so we can very clearly identify all the factors that need to be a part of our least common denominator. So I'm going to factor this denominator here. They both have a GCF of 3. So when I factor out a 3, I'm going to be left with x plus 2. And then I'm going to factor this denominator. They have a GCF of 4. So when I factor that out, I have 4 times x minus 2. Okay, so the least common denominator. So I need every factor to be accounted for, basically. So I need to have a 3. Because this has a 3. This one has a 4, so I need to also have a 4. Now I'm multiplying all these together. I need to have an x plus 2, so I need to include that. And I need to have an x minus 2. So every factor, they need to have, my least common denominator needs to represent all of the common factors. And in this case, there's nothing in common. So basically, I have to include everything to get the least common denominator. So finally, it's going to be 3 times 4 is 12 times x plus 2 times x minus 2. So that's your least common denominator. And it doesn't really matter which order you put your x plus 2 or x minus 2 in, but this was the one that I chose, so the letter for this answer choice would be A. So we're not having to add or subtract, just actually find the least common denominator. Any questions about number 8? So be sure and read your question when you're doing your test, because you may be doing more work than you need to do. Okay. All right, number 9, simplify the complex fraction. Okay, so we have a rational expression or fraction up here, 24m to the 4th divided by m minus 4, all divided by another fraction, 4m to the 9th over m minus 4. So when we're dividing by a fraction, you want to multiply by the reciprocal, or I like to call it keep, change, flip. Keep, change, flip. So basically, we're going to keep the first term exactly the same. So that's 24m to the 4th over m minus 4. I'm going to change this division into multiplication. And then I'm going to get the reciprocal of this denominator here. This whole thing is the denominator of the entire complex fraction. And I'm going to flip it. So I'm going to write m minus 4 on the top, and then 4m to the 9th on the bottom. All right? And so now at this point, you could try to multiply that all together, or what I would think would be the probably the most simple way to go about this would be to go ahead and look for terms we can cancel out. So one staring at me right now, I have an m minus 4 on the bottom. I have an m minus 4 on the top. So I can go ahead, cancel those out. Okay? And so let's go ahead and write what we have left. 24m to the 4th divided by 4m to the 9th. Okay, So if you focus on the coefficients, we have 24 divided by 4. And that can just be reduced to 6. 24 divided by 4 is 6. And then I have m to the 4th over m to the 9th. So like Deanna mentioned, you can go about finding this a few ways. You can write out the 4m's over 9m's and cancel everything in common and see how many you have left. You can use your exponent rules where you're dividing terms with exponents with the same base, so we'll subtract the exponents. If you have 4m's at the top and 9m's at the bottom, then you'll end up with the difference of 5m's on the bottom. Okay? So your final answer is 6 divided by m to the 5th. 6 divided by m to the 5th, and that letter in your test review is letter C. Okay? Any questions about number 9? Feel free to stop and ask any questions that you have. Okay. And so it's 2 of us here, so one's working the problems with you and another one is monitoring questions. So please don't feel like you would hold up anything. Okay, number 10, add the rational expression. Simplify your answer to lowest terms. So remember, in order to add or subtract rational expressions, we must have common denominators. And we don't here. The first rational expression denominator is an x. The second one is a 3x. So we need to have common denominators. So right now, they both have an x, so that's good. One of them has a 3, the other one does not. So we need for that denominator that does not have a 3 to have a 3. So I can multiply it by 3. Easy peasy. But if you multiply the bottom by 3, you have got to multiply the top by 3. Because 3 over 3 is actually just 1, so then we don't change the value of this rational expression. Okay? But also, we don't have to change the second one because it already has that common denominator that we want to use. So the top, we can just distribute this 3 with our 9x and then the 2. So 3 times 9x is 27x. 3 times 2, of course, is 6 over 3x. And then we're going to add that to negative 4x minus 2 over 3x. So this is our goal, to get common denominators, and we've got them. So we're going to just keep that denominator that we worked hard to get, and then combine the top. 27x plus 6 plus a negative, it's just minus 4x minus 2. So I'm going to combine like terms and simplify. So 27x minus 4x is going to be 23x. 6 minus 2 is 4, all divided by 3x. And you want to check to make sure you can't factor anything out that could help you simplify, and we cannot. 23x and 4 do not have a common factor other than 1, so this is our final answer. And that letter for number 10 would be letter D. Letter D. Any questions about number 10? Okay, so we're going to do the switcheroo again. Deanna's going to get back on the mic. Thank you.
One, two, check. Okay, by the way, Justin Bieber got a new album out on Friday. I hope you guys like it.
Yes.
If you attended our first study session, you might know what I'm talking about. My daughter was really crazy about it. So anyway, back to our study session. This is question.
I noticed we have a question for number 3. to go back?
Yes.
We have a question about why can't we multiply both by 3?
Okay, actually we just noticed we had a question and it says why we cannot multiply both sides by 3. Okay, so our goal was to find the least common denominator if we had multiplied both sides by 3, so this side also, then we would get here 9x. So we would have 9x on this side and 3x on this side, which again is not a common denominator. So that's why we did not multiply both sides by 3. That's why we only multiplied this side by 3. Okay, that was a good question. So let's move on to question 11. More complex fractions. So this one says simplify the complex fraction and write your answer in lowest terms. I'm going to use a different method here. Instead of multiplying or finding the least common denominator and doing each one individually and then keeping, changing and flipping, I'm going to multiply everything by the least common denominator. So I'm looking at the denominators of each individual fraction. I have an a here. The 1, I can put that also over 1 to make it a fraction. Then here I got an a, and again I can put this over 1 to make it a fraction. So looking at the a, the 1, the a, and the 1, can you guys, because I know this is the most hardest part of these kind of questions, can you guys tell me what is the least common denominator of all these individual fractions? Okay, the least common denominator has to be a combination of all the denominators. All the individual denominators need to go into the least common denominator. So for example, we have an answer here from the audience that is 1, and 1 is not correct because what about the a? The a does not go into 1, or 1 is not divisible by a. So it has to be a different least common denominator, something that the least common denominator is divisible by each individual denominator. Okay, we got a different answer here. A, that is correct. You can either say 1a or just a because the 1 is imaginary in front of the a. And all the individual denominators will go into this a. A is divisible by a. A is divisible by 1. And again, a is divisible by a and a is divisible by 1. So a is our least common denominator. Now we're going to multiply each individual fraction. I'm going to choose a different color for that. So I'm going to stress what I'm doing here. Let's pick green. Each individual fraction I'm going to multiply by the least common denominator. So multiplying this by a, by a, by a, and again by a. So now I can cross cancel the fractions right here. The a in the denominator and the a in the numerator cancel out. Right here nothing cancels. Then again here the a in the denominator and the a in the numerator cancel, and nothing cancels here. And I'm just going to rewrite my fraction. All I got left from my first one is 10. Then plus from my second one I got 1 times a. So plus 1a or just a. And as you can see, there's no more denominators from this first part of the fraction, and I can move to my denominator. Right here, all that's left from the first part is again a 10. And from the second part, I got 1 times a, which is just minus a. And that's it. Because these are not the same, I cannot simplify any further. This is my final answer. So depending on how the problem looks, one method is easier than the other. And if I have a complex fraction that looks like this, where I do not have the same common denominators of the individual fraction, I would use this method. And this is answer choice D, if I'm not mistaken. Okay, if there are no questions, then let's move on to number 12. Okay, so again, I got a complex fraction, and all these individual fraction looks like factoring. So I would use, in this case actually, because it's so complex, I would use the method that Johnny was using before, of changing this big division bar in the middle to multiplication and then flipping the second one. So I'm going to rewrite it. I keep my first one, my first fraction. I changed the sign to multiplication now, and I flip my second fraction. So x squared minus 2x minus 35 is now in the numerator, and x squared minus 4x minus 45 is in the denominator. Now I can do a whole bunch of factoring. The first one, difference of two squares. By now you guys should be sick of factoring already. Oops, I'm already doing my signs. It's because I know one is positive, one is negative. And then square root of 16 is 4. Okay, done with my first factoring problem. The second one, trinomial. So square rooting the first term, bringing down the sign, multiplying the signs together, and finding the factors of 20 that will add to give me, oops, not 20, to give me 9, of course. So what are the factors of 20 that will add to give me 9? Somebody is working hard here. Okay, so we got 5 and 4. Nice. Thank you. And doesn't matter, both of the signs are the same, so 5 and 4. Let's move on to the next one. Again, a trinomial factoring problem. So an x and an x, bring down the first sign, which is a negative, multiply the two signs, negative times negative is a positive. So now we got the first problem, we got actually different signs, and then finding the factors of 35. Now the different signs indicate I need to subtract to give me the middle number, which is 2. So I'm doing this method with the signs, then I don't have to worry about my signs, and it works 100%. So if you guys worked ahead, what are the factors of 35 that will subtract to give me 2? 5 and 7, bingo. And yes, because the 7 is a larger number, so the 7 should go first if I do my signs, and the 5 second, because I'm getting a negative 2 once I subtract. Good job. Okay, now the last one, also a trinomial factoring problem, and I got a negative and then a positive, and my factors of 45 that subtract to give me the middle number is 4. Okay, bingo. What is it? 9 and 5. 9 and 5, and yes, the larger number goes first, 9 and then 5. Okay, so I think we did the hardest part. Now we have to cancel out whatever is exactly the same. So starting over here, these are the same. Then x plus 5 and x plus 5 in the bottom, and nothing else. So rewriting it with what's left, x minus 4, and then x minus 7, and in the denominator I have x minus 9, and x plus 5. Okay, so this should be my final answer for this problem. And in the packet, this is answer choice D again. So a lot of D's today. If there are no questions, then we can move on. Okay, sounds good. I mean, you guys did the most work on this problem anyway. So this is question number 13. Solve the equation and check your solution. Okay, so basically I would consider that even being two proportions. We got a proportion over here and a proportion over there. And the method that you can do it is by cross multiplying. So I can multiply the x minus 4 by the 3. X or 3 times x minus 4 looks better. And that is equal to cross multiplying the other side, 2 times x plus 2. Okay, so now that looks like using distributive property to get rid of the parentheses, and I'm left with 3x minus 12 on the left side. And again, distributive property. Let's learn some vocabulary today too. 2x plus 4. Okay, so our goal is to solve for x. I'm going to move this x to the left side by subtracting 2x from both sides. So I'm left with x, or 1x minus 12 is equal to 4. And then I'm adding 12 to both sides. Oh, I'm sorry, sometimes I just press a button by accident. It's not as easy as it looks to do this. And 4 plus 12 is 16. So x equals 16. I can check my solution if I get actually a valid answer by plugging my x value back into the original equation. So that will give me 16 minus 4 over 16 plus 2, which should be equal to 2/3. So 16 minus 4 is 12, and 16 plus 2 is 18, which should be equal to 2/3. And you can reduce this fraction. 12 and 18 share a common factor of 6. So if you divide the numerator and the denominator by 6, you should get 2/3, which is equal to 2/3. So this is a valid answer. X equals 16 for this problem, which is answer choice A. Okay, don't see any hands up, so moving on to the next question. This is 14, and we continue of solving equation. So in this case, I cannot use my proportions because I have an addition here of another number. But what I'm going to use, and that's why it's so important to know what's the least common denominator, I'm going to multiply through by my least common denominator to eliminate all the fractions. So again, look at all the denominators, and you can make this a fraction as well, and tell me what is your least common denominator of these individual fractions. Remember, it's a combination of all the denominators. So that least common denominator needs to be divisible by each individual denominator. You are not looking at the numbers in the numerator, you're only looking at the denominators, which is x plus 7, x, and 1. So a combination of all of these would be x and x plus 7. I know this is the hardest part to understand. but you can check the least common denominator. All the individual fractions need to be divisible by, so if the least common denominator is x times x plus 7, then x is in 7 and x is in this least common denominator, and x plus 7 is in this least common denominator. And the 1 is in there too because there's always an imaginary 1 in front. So this will be my least common denominator of all these individual fractions. Now I can multiply each individual term by the least common denominator. So x plus 7 times the first term, which is 6, and then x plus 7 times the second term, which is 7 over x, and then again one more time x and x plus 7 by the third term, which is 6x over x plus 7. Okay, to simplify that, I can cross out numerators and denominators, sorry. So in the first one, nothing cancels out. In the second one, as you noticed, I got an x in the denominator and x in the numerator, cancels out. And right over here, I got x plus 7 and x plus 7, which cancels out. Now I rewrite my problem, and I can multiply all these together. So I'm going to multiply the 6 and the x together. 6x, one step at a time. And then on the second term, what do I have left? I have a 7 and x plus 7. So I can also distribute this already if I wanted to save time. So that gives me 7x plus 7 times 7 is 49. And then on the last one, I'm left with x and 6x. That should give me 6x squared. Okay, I'm not done here. I still got parentheses, so I'm going to use distributive property again. And 6x times x is 6x squared. 6x times 7 is 42x. And then I'm just bringing down the rest of my terms. So as you noticed, I got rid of the fractions, and I'm just solving this problem like every other problem, moving everything to one side, setting it equal to 0, check if you have to factor or whatever cancels out. So I'm going to move this over to the left side to set it equal to 0 in case this is a factoring problem. On this side, this gives me 0 if I subtract, and over here also that gives me 0. And bringing down the rest of my terms, oh, I actually could have combined these two. They are like terms. Okay, so this doesn't look like a factoring problem anymore, but I can combine these two. So 42x plus 7x is 49x plus 49 equals 0. Okay, then I can bring the 49 over to the other side, solving for x. So subtracting 49, 49x equals negative 49. And then to get x by itself, divide by 49 on both sides. Okay, so now x is all by itself, and negative 49 over 49 should give me a negative 1. And that is answer choice B. This looks like a lot of work, but like I said, the hardest part is really to find the LCD, and the rest comes naturally because all those individual things that we've been doing, you've been doing already for a long time now. All right, moving on to question 15, word problem. So Frank can type a report in 4 hours and James takes 5 hours. How long will it take the two of them typing this report together? All right, so this looks like if we have to set up rational equations. And how you do this is look at the first part. This person can do it in 4 hours. So basically, I would say he would do 1/4 of the job. And then if we add what the part of the job that James is doing, so which is 5 hours, so he's doing 1/5, that would equal to 1 whole job. And now we have to solve for x. So we cannot add these two fractions because they don't have the same common denominator. And now we only have numbers in the denominator, so this should be easier for you guys to find the least common denominator. What is the least common denominator of this problem? So we're looking at 4, 5, and you can make this a fraction as well, 1, if it helps you. What is the least common denominator? Don't be shy. It's important that we have the feeling that you guys understand that. Because if you cannot find the least common denominator, you will have to stop right here. And you're losing a lot of points. Least common denominator.
Yay!
Yes, 20. You see, so with numbers, it's easier for you guys. If variables are involved in the denominator, then it gets much harder. Okay, so we're multiplying each individual term by the least common denominator. I'm going to change my color so it doesn't look that messy. Multiplying here by 20, multiplying this by 20, and also multiplying here by 20. When I multiply by 20, both of them share 4, so 4 goes into 4 once, 4 goes into 20 5 times. Here, both of them sharing a 5, so 5 goes into 5 once, 5 goes into 24 times. Nothing cancels, so I'm rewriting my problem, eliminating the fractions because I don't like fractions. So 5 times 1x is just 5x plus 4 times 1x is 4x, and 1 times 20 is 20. Combining like terms, I get 9x equals 20. Dividing by 9 by both sides, on both sides, leaves me with x equals 20 over 9. I cannot reduce this fraction. I could convert it into mixed number, but I believe in your answer choices, it's fine to have it as an improper fraction. So if you look at your packet, 20 over 9 is actually a valid answer, and this is answer choice A. So in this scenario, this number basically means that it will take them 20 over 9 hours to type together. So if this doesn't really mean nothing to you, you can always convert it into a fraction, into a decimal. What is 20 over 9 as a decimal? 2 point something, right?
Yeah.
So approximately it would take them a little bit more than 2 hours to do the job. But 20 over 9 is fine. I just wanted you guys to have like a feeling, what does this mean pertaining to the problem? Okay, I'm going to switch with Johnny now again to do the next 5 questions for you. And please feel free to type if you are stuck on something or still confused.
Okie dokie, and I'm back. All right, so number 16, write the number in scientific notation. So we've got 39,000. Right now, if you were looking at this and you had to put the decimal place where it belongs, it would go here. That's a whole number. So that's technically where your decimal point is. But to put in scientific notation, we want to change this number to a number between 1 and 10. So by moving the decimal place. So basically, if I move the decimal place, like if I moved it here and put the decimal here after the 9, then I made this number be 39. But that's not between 1 and 10. So I'm going to move it one more spot here. And if I put the decimal place in between the 3 and the 9, that'd be 3.9. That is between 1 and 10. Now, I need to multiply this by 10 to a power to represent these decimal places that we moved. So basically, now 39,000 is a large number, so your exponent for your 10 is going to be a positive number. If this were a very, very, very small number, like 0.000039, it would be a negative exponent. But this is a large number, so we move the decimal 1, 2, 3, 4 times to get 3.9. So it's actually 3.9 times 10 to the 4th power. Okay? So that's how we can rewrite this number into scientific notation. And just make sure you want to move the decimal place wherever makes this number be between 1 and 10. So, any questions about this? This was the only problem on the review, but yeah. So that letter is letter A. Okay. 17. Express your answer with positive exponents. Assume that all variables are non-zero. So you've got a large product raised to the negative second. And you can go about this a few different ways. I am going to go ahead and eliminate the parentheses and raise every single term to the negative second power. Okay, so we've got 5 to the negative second. I have x to the negative fifth raised to the negative second. I have y to the fifth raised to the negative second, and z to the negative ninth raised to the negative second. Okay, so now let's multiply my exponents. So I'm going to leave this 5 to the negative second alone for now. So a power raised to a power, you're going to multiply. So negative 5 times negative 2 is positive 10. Okay, 5 times negative 2, y to the negative 10. And then negative 9 times negative 2 is positive 18. Okay, so we want positive exponents. So we need to take care of our negative 2 exponent and our negative 10 exponent. So in order to make them positive, I want to move them to the other end of the fraction. This is like a large whole number. They're all in the numerator, but I can make this 5 to the negative 2 have a positive exponent and this negative 10 a positive exponent by moving it to the bottom. Now my x to the 10th and my z to the 18th, they're already having a positive exponent, so I don't want to move them. Let me erase that so it doesn't look like a, where, this, okay. Oh, I think that's an exponent or something. This going to throw me off. Okay. Alright, so I'm going to keep my x to the 10th at the top, and I'm going to keep my z to the 18th at the top. I don't need to move those. That's an 18. Oh, Lord. Okay, over. Now, 5 to the positive 2. I'm struggling right now. And then y to the positive 10. And then I'm going to go ahead and simplify and evaluate 5 squared, which is 25. So x to the 10th, z to the 18th, over 25, y to the 10th. So that final answer is going to be letter D. Letter D. Any questions about that? Okay, number 18. Same thing. So we've got quotient raised to a -2. I'm going to just raise every single thing to the -2nd power. So x to the -2nd, y to the 5th to the -2nd, over x, well, I guess I'll go down something different. I just know x to the 6th to the -2nd, and then y to the -2nd. What I just noticed in working this out, you also, and probably this would have been the easier thing to do, would be to simplify in here, because you can, and then raise the -2nd. But either way, we can still get the same answer. So I'm going to have x to the -2nd, y to the -10th, over x to the -12th, and then y to the -2nd. So I like positive exponents, so I'm going to go ahead and make my exponents positive before I kind of reduce. So every single exponent's negative, so I want to flip all of them. So I'm going to move what's at the top to the bottom and what's at the bottom to the top. So that'll be x to the +12th, y to the +2nd, over x to the +2nd, and y to the +10th. Okay? So now that my exponents are positive, it's a little easier for me to simplify. So I have x to the 12th over x to the 2nd. If I subtract my exponents, I'm going to be left with x to the 10th at the top. And then I have y to the 2nd over y to the 10th. If I subtract, I'm going to have y to the 8th. And since my exponent is larger at the bottom, that's going to go to the bottom. So my final answer is x to the 10th over y to the 8th. Okay? But again, you could have solved this in a different order, and that's okay. It kind of depends on what you see first. But you could have simplified this to be x to the 5th here at the bottom, and this would be y to the 4th at the top, and then you would still got your answer. Any questions? Feel free to stop us. Okay, number 19, simplify the expression. So we have a radical expression, and I like to split everything up. So I'm going to take the cubed root of 216 times the cubed root of x to the 4th times the cubed root of y to the 5th. I just broke it apart. Now, the cubed root of 216 is a perfect cube. That's actually just 6. Okay, the cubed root of x to the 4th. So I'm going to just write on the side here. Okay, so x to the 4th is actually 4 x's. So it's 1, 2, 3, 4. So we're looking for the cubed root. We want to look for 3 of the same thing. So we have 3 x's. We have a group here. So you would write that on the outside, and then you have 1 left over. So that's going to stay in the radical, under the radical sign. Now, a quick way to do this without having to write it all out, that I like to look at it here and say, okay, 3 goes into 4 how many times? It goes in there 1 time. So I'm going to have that 1x to represent that 1 time 3 goes into 4. But there's a remainder of 1, so that leaves me with an x left over under the radical. So using that same kind of thinking, 3 goes into 5 1 time, So I'm going to have my 1y to represent that one time, but I have 2 remaining. So that's going to be y squared underneath. So now I'm going to combine it together. Everything on the outside, I'm going to write together. So that's 6x, y. And then everything under the radical, I'll write together, x, y squared. So that's my final answer. So make sure, pay attention, this is a little 3, it's called an index, and that is letter D, answer choice. Any questions? All right. Okay, number 20. So simplify. So we've been talking about like terms. You can also have what's called like radicals. So like radicals are when they have the same index number. So like if they, for this problem, they're all the square root. Like there's not a cubed root in here. They all are a square root, and they must have the same radicand, the same number under the radical. So right now they don't. They're all 3 very different ones. So we want to reduce it and try to get like radicals. All right, so if you have good knowledge of your perfect squares and you know if it's a factor of these numbers, you can go about it that way, or you might be like me and do a factor tree to help you find that out. So, and sometimes you have to just do a little division, to figure out what's a number that can divide evenly into the number that you're questioning. So 147. So I'm going to do that over here on the side. So when I was trying to figure it out, I noticed that 3 can go into 147. And 3 times 49 gives you 147. Now, what's great, 49 is a perfect square. So I'm actually taking the square root of 3 times 49. So I'm going to leave it like that. And so the square root of 49 is 7. So I'm going to bring that on the outside. So that's 7. And the 3 is going to stay underneath. But don't forget, this negative 5 is out here. So that's negative 5 times, that's 7. And so now we have the square root of 12. So think about a perfect square that's a factor of 12. 4. Okay, so what times 4? 4 times 3 equals 12. So I can take the square root of 4, which is 2. I still have the 3 under the radical, but don't forget this is minus 6 times 2 root 3. And then I want to think about a perfect square that's a factor of 108, and 36 is a perfect square that's a factor of 108. So 36 times 3 equals 108. So the square root of 36 is 6. Don't forget that's minus 5 times 6 times the square root of 3. So I just want to make this clear for you guys. Let's see. These are my radicals that I simplified. Okay? That came from here, here, and here. That negative 5, that negative 6, and the other negative 5, that's the ones in the front. Just want to kind of make that clear. All right, so negative 5 times 7 is negative 35 root 3. Negative 6 times 2 is negative 12 root 3. And negative 5 times 6 is negative 30 root 3. So we have like radicals. They are all root 3. So you almost think of it as like terms. Like if it was negative 35x minus 12x minus 30x, you could combine that. Well, these are like radicals. So we're basically going to combine those outside numbers, and that's all going to be times root 3. And so negative 35 minus 12 minus 30 is negative 77 times root 3. So this is my final answer, and that is letter B. And so like I said, sometimes you have to kind of play around, and you may have to divide a few numbers to see what's a perfect square or not, or what's a factor of the number, and that's completely fine. But eventually you'll get to this point to where you get like radicals. If it did not have the same number underneath the radical and the same type of radical sign, then you could not combine them together. Any questions about number 20? All right, so we're going to switch with Deanna. Let's see.
Okay, I'm back on the mic, and thank you so much to Johnny. She actually has to go and teach her own class now. So thank you for joining us today. We hope to see you during the final review session again.
I'll be there.
Okay, that sounds good. And let's continue with the last 5 questions. So it says multiply using for. That already gives us a little hint of what to do here. So we can use falling to simplify this problem. And falling works like that. You have to multiply the first times the first times the second, and then the second times the first, and the second times the last. But let's start with the first part. So the square root of 7 times the square root of 2. When you're multiplying radicals, you just multiply the numbers and keep them under the radical. So 7 times 2 is 14. Then first times last, so square root of 7 times 7, if you're multiplying a radical times a number, just keep the same thing together. I can put an imaginary 1 in front, and I'm going to multiply this imaginary 1 times the number 7, which is a positive 7, and then the square root has nothing to multiply by, so it just hangs on. Then the second times the first, and the same thing, I have a number that needs to be multiplied by a number, so I can add an imaginary 1. So 2 times 1 is just 2, and then the radical just comes down, it has nothing to be multiplied by, and then second times last, so 2 times 7, now these are only regular numbers, it's a positive 14. Okay, so now we have to check if there's anything we can combine, and to be able to combine they need to be like terms, and they need to have the same index, which they do have. They're all index 2, even if you cannot see that, but they are, you know, square roots, and they need to have the same radicand, which is 14, 7, and 2. They don't, so they are not like terms. I can check if individually I can simplify them, but there is no perfect square in the number 14. 7 is already prime, so I know there's no perfect square, and 2 is also a prime number, there's no perfect square. So I believe that this is our final answer, because none of these can be combined, they are not alike. And in the packet, this is answer choice A. Okay, so on the test you should definitely look if there's anything you can simplify, but that's like the previous problems been done before. Okay, 22. This one says rationalize the denominator and simplify. So rationalizing means that I need to get rid of the square root in the denominator. And to do that, I can multiply by the conjugate. The conjugate of 9 minus the square root of 7 would be a 9 plus the square root of 7. But what I do to the bottom, I also have to do to the top to keep the balance of this fraction. Okay, so in the numerator, I'm just going to distribute the 5 to each term. 5 times 9 is 45. And 5 times the square root of 7, numbers times numbers, so plus 5, and then the 7 just hangs on, the square root of 7. Now the denominator, I have to use FOIL to simplify that, and remember it's first times first, which gives me 81, first times second, which is plus 9 square root of 7, second times first, and negative 9 square root of 7, and negative, then the last times the last, so negative square root of 7 times square root of 7, which gives me a negative 49. If you do these quite some time, you should realize the reason why we multiplying by the conjugate is we want this middle term to cancel out. So we are left with just 81 and a negative 49. And this one always is going to be a perfect square if we're using multiplying by the conjugate. So the square root of 49 is just 7 minus 7. And in the numerator was really nothing that we could have simplified, so I'm just going to bring it down. And now 81 minus 7 is 74. And this was our goal. We got rid of the radical in the denominator. There are no radicals allowed in the denominator, and that's what you call rationalizing the denominator. So if I'm looking at the 45, the 5, and the 74, sometimes you are able to simplify because they would have or share a common factor, but in this case I do not see any common factor because 74 is not divisible by 5, and this has 9 and 5, and none of the other two is divisible by 9, so this should be my final answer. I cannot simplify any further. And this is answer choice B. Alright, if there are no questions, let's move on. This is number 23. It says solve the radical equation. So solving radical equations, the first step is that the radical is all by itself on one side of the equal sign. In this case, it's already. So we can go to step 2, where we're using the squared method to eliminate the square root. So if I would square both sides, then on the left side the square would cancel out the square root, and I'm left with 10q minus 9. And on the right, 9 squared gives me 81. Okay, so I'm solving for q. To do that, to get q by itself, I'm going to add 9 to both sides. And with some letters I have to be really careful because they look alike, and then I might going to confuse myself and think they are the same and try to combine them. But in this case, I'm sorry, this meant to be a 9 because I'm dealing with q's here. So 10q and 81 plus 9 gives me a 90. My last step, divide by 10 on both sides, and that is q equals 9. So my final answer for this problem is Q equals 9, which is answer choice A in your review booklet. All right, moving on to question number 24. We're almost there. So 24 says, rewrite without rational exponent and simplify as possible. So first step, let's rewrite this without rational exponents. So this number actually becomes the index of a radical. So this index says 3, so we actually have the cube root. And this one, the numerator of the fraction, becomes the exponent. So the second step now is to simplify inside the parenthesis and to a cube root 27. I've been dealing already with the number 27 for quite some time that I automatically know that this would be 3. But you can also use your calculator. You have an option on the calculator which is a math on the upper left hand side, and under that you find the cube root if you ever wonder. So now I got 3 to the 4th power, and that is nothing else than saying 3 times 3 times 3 and times 3. So that gives me 9 times 9, and 9 times 9 is 81. So my final answer for this problem is 81. That's answer choice C. Okay, so moving on to our last question. This one says, use the properties of exponents to simplify and write your answer with positive exponents. So even though these are numbers, but they are the basis of the exponent, so they are the same. We can use the rules for exponents, which means if we multiply, what we do with the exponents, we add them. So 6, 1 over 9 plus 8 over 9. The fractions now have the same common denominator, so we do not need to find the same common denominator. We just can add the numerators, which gives me, oops, that 6 looks kind of weird. Okay, which gives me 9 over 9. Now 9 over 9 is nothing else than 6 to the 1st power, which is nothing else than just 6. And that is answer choice C. Okay, so I'm just checking if anybody has any questions, but it doesn't seem like it. So let's move on to our test 3 info slide. And this is just, giving you guys basic information about test 3, which will be very, very similar to the review session that we have just hosted. So there, if you watch the review session and you do the online review on Blackboard a couple of times until you have 80% or higher, then you will be just fine going to take your test 3 this week, which opened actually today, and it will be open until Monday next week until 9 p.m. So make sure to arrive 2 hours before 9 p.m. because the test got 2 hours for you to take it, so the testing center will not let you in if you are late. So you needed to be there at latest by 7 to be able to take your test on Monday, but don't wait until the last minute because you never know what happened. Then you're allowed to bring your graphing calculator, but only the TI-83 or the TI-84, no calculators that are higher than that. You can bring your pencils. You need your VID photo ID. They will check those. If you don't have it, they won't let you take the test and you did all this trip for nothing. This test has to be taken in the Osceola Campus Testing Center. That's where I set you guys up. So no other testing site will have your information and will let you take the test. You need to come to the Osceola Campus Testing Center. This CRN of this course is 14221. They might ask you for it, so you should know this. This is MAT1033C, and if they're asking you for instructor, you can use either my name or Dr. Pedoni's name. Below you find the hours of operation for the testing center, so you can make arrangements to come in at any of these days or times all the way until Monday next week. I will be available all week. You can contact me by email. You can set up personal or group study sessions this week if you feel like you need a little extra help before actually taking the test. I am available. I will try to respond as quickly as possible. And thank you so much for joining us live today, to our participants. And I will be staying online for a little longer to answer any questions that you might still have. And I wish you guys good luck on test 3. Okay, I have a question here. Somebody is asking, where can I rent a calculator on the campus? On the Osceola campus, there are actually 3 locations where you can rent a calculator. The location that I know you can rent it for the most time, which is 4 hours, is in the Math Depot, which is located in Building 4, Room 121. You just tell the front desk that you want a calculator. They will send you to the back. You need to show them your VID and you can get a graphing calculator for 4 hours to take it with you to the testing center if you do not have your own. 2 other locations are in the library, which is in the 2nd floor, in the same floor that the testing center is, in Building 4, and a 3rd location where you can rent a calculator on the Osceola campus is in Building 1, Room 143, which is actually the Academic Systems Lab, but it's kind of far away, so I will probably check out those other 2 locations first as they are closer to the testing center. But if they run out of calculators, which hardly ever happens, but then there's this 3rd location in Building 1, Room 143. Very good question. I have another question which says, how do the study sessions work? Which I don't really know and what specifically you meant by that. So if you want to type in a little bit more clearly what you are asking, but basically what I'm going to do now is I will download this recording to YouTube and then make it available to everybody for them also to be able to watch. You guys that are participated live can take their Blackboard review. If you looking for extra credit, you have to take it until you got 80% or higher. Then you will receive extra credit towards your test. And also you can attempt the test correction after you have taken your test and after it's available to everybody, which means after the due date next Monday, to also receive extra credit towards your test. All right, so I think there are no other questions. So I'm going to stop the recording now. Again, I wish you guys good luck, and if there's anything else I can further assist you guys with, just email me.